students, today in this video we are going to complete molecular orbital theory. Okay, so here in the last videos of molecular orbital theory we have discussed the molecules which are having total number of electrons less than or equal to 14. So if the number of electrons are greater than 14, then I told you there is another electronic configuration. So that is sigma 1s, sigma star 1s, sigma 2s, sigma star 2s. It is greater than no. So sigma 2pz, pi 2px is equal to pi 2py. Then pi star 2px is equal to pi star 2py. Sigma star 2pz. This is the electronic configuration we have to follow, and here today we are going to discuss one of the important molecule which is asked many times, okay, many times in your JEE exams, okay. So here that is oxygen molecule, okay. So here one by one we will discuss oxygen molecule and O2 plus oxygenal ion and O2 minus, it is superoxide. O2 2 minus, it is peroxide. Now here today we are going to discuss the stabilities of these oxygen molecule. Oxygenal ion means O2 plus, O2 minus superoxide, and O2 2 minus, which is peroxide. We are going to discuss about the bond length, bond orders and the magnetic natures, okay, one by one. First you write this, we'll write electronic configuration for oxygen. So here what is the electronic configuration? Here it is 1s2, 2s2, oxygen 8, altogether 16 electrons, 2s2, 2s2, 2pz2, and here 10, 12, 13, 14, 15, 16, okay, 1, 2, 3, 4, 5, 6, 7, 14, 15, 16, okay. This is how you have to write the electronic configuration. Now calculate the bond order. So I told you, no, violate this one. Now calculate bond order. Bond order for oxygen molecule, half of the difference between number of bonding. How many bonding are there? 1, 2, 3. 3 2s are 6 minus anti-bonding 2. So 4 divided by 2, 2. Bond order is 2. And here unpaired electrons are there. So it is paramagnetic. And it is paramagnetic with the bond order of 2. Now you calculate for O2 plus. So O2 plus will be obtained by the loss of, it is oxygenal ion. You write in your notebook. I clear these ones. Now here the electronic configuration for this one. So 16 minus 1, which is equal to 15 electrons, means this is the electronic configuration for this one. So here calculate the bond order. Bond order is equal to half of the difference between how many bonding. Here there is no change in the bonding orbitals. No, 1, 2, 3, 6. So 6 minus 1, 5 by 2, 2.5 unpaired electron, and it is paramagnetic 2. Okay, O2 minus, which is obtained by the addition of 1 electron. So here 16 plus 1, 17 electrons. Now calculate the bond order for this one. What is the electronic configuration if it is 17 electron? 16 and 17. Okay. Now calculate the bond order. Bond order is equal to 1 by 2. There is no change in the bonding. 6 minus, as usual, 3. 3 by 2, which is equal to 1.5, and they too contain an unpaired electron, so it is also paramagnetic 2. O2 2 minus, it is obtained by the gain of 2 electrons to the oxygen. Altogether 18 electrons. So the electronic configuration will be like this. So here bond order is 1 by 2. Here 6 minus. How many anti-bonding electrons? 1, 2, 4. So here 1 will be the bond order, and it is diamagnetic. Clear? Clear? Now, by looking at the bond orders, you write down the stability order for oxygen, oxygenal ion, and superoxide and peroxide. So here what is the bond order here? O2 plus is having the bond order or stability order. So here O2 plus is greater than this. After that O2 plus and O2 oxygen. After that O2 minus, and this one O2 2 minus. This is the stability order. For the oxygen. Here oxygenal ion, oxygen, superoxide and peroxide. This is the stability order. Now write down the bond length order for the bond length. Okay, you write this one. Okay, can I clear this one? Now here for these three you can calculate the magnetic moment also by using the formula square root of magnetic moment is equal to n into n plus 2 Bohr magnetons. So by applying this formula here, where n is number of unpaired electrons. So here how many unpaired electrons are there in the first case? Means oxygen 16. Oxygen 16 means here these two are the unpaired electrons, isn't it? So here where n is equal to 2. So n is equal to 2 means if you substitute n is equal to 2, which is square root of 2 into 2 plus 2, 4 plus 2, square root of 8. Okay, a square root of 8 Bohr magnetons. And here if you look at this one, O plus means loss of 1 electron, 1 unpaired electron. So which is equal to square root of 1 into 1, 2 plus 1, 3, 3 into 1, square root of 3 Bohr magnetons. And here O2 minus means 16 plus 1, 17. 17 means here 1 unpaired electron, again square root of 3 Bohr magnetons. Okay, this is how you can calculate the magnetic moment for this one. Okay, magnetic moment. Now this is the bond order. What is bond length? Can I clear this one? Now the bond order for oxygen is here O2 plus greater than O2 greater than O2 minus greater than O2 2 minus. This is the bond order, and here we know bond order is inversely proportional to bond length. So here if you are asked with bond length, you reverse this order. O2 2 minus greater than O2 minus O2 than O2 plus. Okay, it is very important, and it was asked many times in your JEE exams. Okay.